Alright, so I'm going to show you an example of how to solve one of these problems using the equation from the first law of thermodynamics. Now if I was going to write this equation, if you remember, it's a change in U equals Q, transfer of energy via heat, minus the amount of work done. So this really tells us, if we look at this equation, the change in U is equal to two things, either transfer of energy through heat, and then the work done. And it can be both, or maybe it's just one, okay, of them. And sometimes these can be, one can be a little bit of transfer of energy, and a lot of work. So sometimes we can even ignore these small changes of heat or work and really focus on the one that's much larger. So this is internal energy, right? This is heat, and this is work. So then we just have to see what we have. We have 135 joules of work is done on the refrigerant. So this tells us that the work is negative. It's done on the system itself. So the W work is equal to negative 135, and it's joules because it's energy. It says if the internal energy of the gas increases, that's going to be your change. So change in U increases by 114 joules. Same unit, right? And what is the total amount of energy? What is the total amount of energy that has been transferred is heat. So really we're solving for this. Okay. And it says, has energy been added or taken away from the refrigerator as heat? So then we just plug into our equation. Now we could move it around and solve for Q. We don't necessarily need to do that. I just like to sometimes just plug it in. So we go 114. That's your change in internal energy equals Q. That's what we're solving for. Minus a negative 135. So then we see this minus and negative. We just change the sign of this and we add them. So in the end, it's Q plus 135. And we'll just get rid of these. We don't really need these anymore. They're a little smaller. Where's my little thing here? Okay. That's going to be Q plus 135. So then we are going to minus 135 using our algebra. That's going to cause these to cancel. Then it's going to be minus 135. That's going to give us a negative 21 joules, right? Equals Q. Okay, and so then that is the amount of energy that's been transferred. And then it says, has energy been added or taken away? So it's a negative. So this is lost, right? So then it's taken away. And that's kind of how you use this equation. Just plug in what you know. And then remember, is it being done on the system, or is the system doing work? That determines whether work is negative or positive, and whether it's a negative heat or a positive heat. Negative heat is losing this lost from the system. If it's positive, it's being gained by the system. That's kind of how you solve these. It's a pretty easy problem. Try a few of these. This is practice B, and see if you can get that done. Should be no problem for you.